Hello everyone, welcome to Engineering Archives. Let us look at practice problem number 4 for this chapter. So the question says, at a given instant, position of a plane A and a train B are measured relative to a radar antenna at O. Determine the distance d between A and B at this instant. To solve the problem, formulate a position vector directed from A to B and then determine its magnitude. So the question gives us the way to solve the problem, and that is uh, find the vectors from O to A and O to B and then use a vector triangle to, or basically just after finding these two vectors in their Cartesian forms, add them to find their resultant vector. We will also use a vector triangle because we need to get a sense of what direction these two vectors OA and OB need to be in order for us to get the right resultant vector from A to B. So let's start with drawing the vector triangle first, just to get an idea of what we are finding. So let's suppose this vector is the vector OA. Let's just call it the A vector. And let's say this is the B vector. And we need to find the length vector from A to B. So this needs to be, since this is point A and this is point B, so this needs to be our resultant D vector. So as you can see from this vector triangle, we need to set up the vector A and the vector B in such a way that this triangle does not violate the vector triangle rule. And this rule says that the tail of the first vector needs to touch the tail of the resultant vector, and the tip of the last vector needs to touch the tip of the resultant vector D. So from this diagram we can see that for this vector A, we need to make its direction from the point A towards O, so that its tail touches the tail of the resultant vector D. And similarly for the other vector B, we need to direct it in such a way that its tip touches the tip of the resultant vector D. So it needs to be in this direction. So from this diagram we can see that the vector OA is directed towards the point A. So in other words, we will actually need to find the vector AO, which should be in this direction. And after that we can find the vector B, which will be in this direction. And once we have these two, we can finally solve for the resultant D vector, which will be in this direction, just like we drew in our vector triangle right here. So let's start by finding the vectors OA and OB. Once we have found the vector OA, we can flip that to make it AO by just multiplying it by a negative sign. So let's start by finding the length vector OA. Notice that we don't have any length measurements in this diagram, but they have given us the angles, so we will be using the angles to find the components along the x, y, and z directions. So let's get started. Length vector from A, or let me just write it down as OA. OA would be, the x component is going to be 5 multiplied by cos of 60 times cos of 35. 5 cos of 60 cos of 35. But notice that the OA vector is towards the negative x direction, so there is a negative sign before this component. For its component along the y-axis, we can see that this component is going to be 5 multiplied by cos of 60 times sine of 35. And this component is also directed towards the negative y direction, so there is going to be a negative sign. And lastly, we have the component along the z-axis, and that one is simply going to be plus 5 sine of 60. So this is the Cartesian form of our first vector OA. Let's solve these coses and sines to get their numerical values, and those are going to be negative 2.048i minus 1.434j plus 4.33k. Okay, now that we have the Cartesian form OA, we need to flip this to make it AO. So in order to make it AO, all we have to do is simply just flip the signs of this vector, and we would get 2.048 plus 1.434j minus 4.33k. Now that we have the first vector that we need, we will move on to find OB. For OB, we will also use the angles to find its components along the x, y, and z directions, and those are going to be 2 cos of 25 multiplied by sine of 2 degrees, and this is going to be the I component. Notice that this is directed towards the positive x direction, plus 2 cos of 25 cos of 40, and finally negative 2 sine of 25, since the component along the z-axis is towards the negative direction, negative z direction. Now we will simplify these trigonometric identities to get their numerical values, and we will get 3 point, we will get 1.165i, 1.3884j minus 0.84, and the last component is going to be minus 0.8452. So now that we have both the vectors, we will simply need to add them up to get the resultant vector. So the resultant vector, the Cartesian form of the resultant vector, is going to be AO plus OB. And so once we add them, we can find the magnitude of the resultant vector. So just add the respective x, y, and z components together. Okay, so once we add the i's, the j's, and the k's, we have with 3.213i plus 2.8225j minus 5.18k. So this is the Cartesian form of our resultant vector, and to find the magnitude of the resultant vector, in other words, to find the length of from point A to point B, we will simply use the magnitude formula, which is sum of the squares of all components squared plus. And so the length that we get is 6.72 kilometers. So this was a simple procedure for this question. Thank you very much. See you in the next video.